welcome back. This is our second lesson on maneuvering boards. In the first lesson, we talked about finding the DRM, SRM, true course, true speed, CPA bearing, CPA range, CPA time, and determining what type of situation we're in. In today's lesson, we're going to be talking about finding course to avoid. So what does that mean? Well, when we're at sea, we want to try and prevent collision. And one of the best ways to do that is to open up CPA between us and a different vessel. And of course, all of our maneuvering will be in accordance with COLREGs, the rules of the road. I'm going to go ahead and work through a practice problem. If you were paying attention in the first video, you'll find that the numbers are the exact same as the explanatory problem that we did in that first video. So I'm going to go ahead, I'm going to work through these steps rather quickly, but then once we get to the actual course to avoid, I'm going to break it down piece by piece. Course to avoid is one of the most difficult mode boards in my opinion. All right, so our vessel is on course 020 at a speed of 14 knots. So 020, 14 knots. Label the points. And at time 1303, we spotted contact down bearing 070 at 9,000 yards. This is M1. 3 minutes later at time 1306, the same contact bears 071 at 7,600 yards. 7,600 yards, 071 gives us M2 right here. Draw the line across. And we can also parallel it from the R, E to R vector, because we know we'll need that later. We can figure out our CPA bearing. A CPA bearing of 154 degrees true. And like I mentioned in the first video, there's always going to be a little bit of error every time you do a mode board, so these numbers might not be the exact same as the first time we went through, but usually on an exam or even in real world, there's always a little bit of fluctuation that you might have. So on an exam, you're usually allotted a couple degrees of error. Real world, obviously you want to be as close to accurate as possible. All right, so 154 degrees true is our CPA bearing. Direction of relative motion is 244 degrees true. We can go ahead and we can figure out our SRM. Distance between M1 and M2, 1,500 yards. That happened over 3 minutes. We plot 1,500 in 3 minutes. The nomogram. That gives us an SRM of 15 knots. Use a 5-to-1 scale in our plotters. Bring them up to 15. Plot that 15 on the line we drew earlier, our SRM line. Connect the points. And we get that the contact is on a true course of 309 degrees true with a true speed (5-to-1 scale), 11 knots. CPA time, distance between M2 and CPA. 7,500 yards with an SRM of 15 knots. Gives us a time to CPA 15 minutes. All right, so now we're going to go ahead and work into our course to avoid part of the mode board. Like I said, this is pretty challenging and it does require knowledge of rules to the road. So Our commanding officer, we called up to the commanding officer a little bit earlier. We gave him the contact report. He said, I'm not comfortable with what was that? We said 1,000 yard CPA or 700 yard CPA. I want to open that up to 4,000 yards. So he told us at time 13:08, so that's 2 minutes after the 13:06, the last hit that we have, he wants us to alter course in order to get a 4,000 yard CPA. All right. So what I like to do, just as a visual reference, is draw a line around the 4,000 yard range ring. This will just help us visualize everything a little bit better. And the CO said that he wants us to do this at time 13:08, make this maneuver at 13:08. So that's 2 minutes later. So we know that this contact has an SRM, speed of relative motion, of 15 knots. So we want to figure out how much further is this contact going to travel relative to us in 2 minutes. We use our nomogram, SRM at 15 knots, 2 minutes time on the timeline, and we determine that this contact will travel an additional 1,000 yards. So we can go ahead and plot 1,000 yards, figuring out what 1,000 yards look like using the range rings. Putting the pointy tip on M2, drawing that line on the DRM, and this will be at time 13:08. This is where the contact will be. So 13:08. All right, so the commanding officer, the CO, he wants us to open up CPA to 4,000 yards. What we have to do now is take the ruler, and once you get a little bit better at doing the mo boards, it'll become a little bit more apparent which direction you have to do this in, but we make a line tangent to the 4,000 yard range ring. So send a line from M3 tangent to the 4,000 yard range ring. And then what we have to do at this point is bring the slide rule back to point M. All right, I'm going to do this first step and then explain why we're doing it this way. So we're not changing speed, so we're going to continue going at 14 knots. We're going to take our pen and draw a line in the reverse direction. All right, so why do we do this? Well, in accordance with the rules of the road, one of the best ways in order to, if we find ourselves in a crossing situation, we want to avoid crossing the bow of the contact who is the stand-on. So that means the best course of action, 9 times out of 10, is going to be to alter course to starboard. E to M vector, this is the contact, they're not going to change their course and speed. We're maneuvering for them. So their true course, their true speed is going to remain the same. Our true course and our true speed is going to change. So we want to alter course to starboard. If we were to have gone this direction, make the line M3 tangent to the 4,000 yards, bring it back to the M point, then extend the line out, we would come to port. We don't want to do that. So like I said, this becomes a little bit more intuitive after you do course to avoid mo boards more often. But that is one of the most challenging parts, is determining which way you're going to draw the tangent line. All right, so we're keeping the same speed of 14 knots. This part is easy. All we have to do, figure out 14 knots on our 5-to-1 scale. Put the point at the center. Figure out where it intersects, that line we just drew. And this gives us a new course to drive. We'll call this R1. And we find that if we wanted to avoid that contact by 4,000 yards, maneuvering at time 13:08, the new course to drive would be 0, 9, 6 degrees true. Suppose, though, that the CO said he wants us to keep the same course that we're driving, but he just wants us to slow down. This part's even easier. We just take that new line that we drew. We figure out where it intersects the old line, the original e to r vector. Because remember, e to r on the original vector is on a course of 0, 2, 0. So we keep that course. We just figure out where the lines intersect. We take our plotters, figure out that size, bring it to the 5:1 scale. And we determine that if we wanted to maintain an original course of 0, 2, 0, but slow down in order to open up CPA, we would have to reduce our speed to 4 knots. So now we want to figure out what is the new time to CPA. So like we did for the original problem, we use the new DRM line, which is that tangent line that we drew. Bring it over. Make a tick mark. And this is where the new CPA will occur. We want to figure out our time to CPA, so we figure out the distance between M3 and the new point. That is 5,000 yards. The SRM that we're going to use is the new SRM that we determined, so the new M to R1 vector. Take our plotters, M to R1, bring that to the 5:1 scale. We have a new SRM of 24 knots. Go back down to our nomogram. 24 knots SRM with a distance of, what do we say, 5,000 yards. Gives us a CPA time of plus 7 minutes, and that's going to be plus 7 from time 13:08. And that is how you do a course to avoid maneuvering board.